would put this device around your neck here. Okay.
I'm game.
Okay. I think we're good to go. Go ahead.
So what have you been developing?
So what we've developed is a communication technology that captures neurological information from the brain when a person has an intent to communicate. We're able to take those signals and turn those into speech or into control signals that can move devices like a wheelchair. Now we're developing this for people with severe disability. So due to disease or injury, these people don't have the functionality that you and I have, the ability to speak or also move. So this technology was developed out of the University of Illinois and it's been supported by the Technology Entrepreneur Center, which is headed by our advisor, Andrew Singer, who's here today. I think he's over here. Want to say hi? And we started a company to commercialize this technology about 3 years ago called Ambient, and also the device here, which is known as the audio.
So how does it work?
So the device works by basically when a person has an intent to communicate, the brain will send a neurological signal. Now this neurological signal is something that the brain uses to give you all the functionality that you have. So this ranges from controlling your heart all the way to what's allowing me to actually speak right now. So to give you a better idea, we had hooked you up to the device here.
Okay, and so how does this device work?
So the device itself that you have around your neck has the audio sensor in it. The audio sensor captures the neurological activity and digitizes it using analog and digital signal processing. And we send it through this wire over to this laptop where we're running LabVIEW. And if you want to take a look at this graph here, we're showing your neurological input as a function of time.
So is that what I'm thinking?
No. Now you notice as you said that there needed to be an intent to communicate. Obviously when you vocalize the activity, there is an intent to communicate. But now these signals can be present whether or not the person actually speaks. So if you want, you could give it a try now.
This is really neat stuff. How does the audio translate my neurological activity into speech?
Yeah. So in order to perform that process that was just there, we have sophisticated signal processing algorithms that we developed in LabVIEW.
So how did you apply algorithm engineering to the process?
So many of you are most likely familiar with digital signal processing, where the signals are well known, they're man-made. And there's a rich set of tools that are available to you. But now for a biological system like this, there's a lot of variation introduced due to the physiological parameters and just how the brain naturally works. So in order to overcome those, what we did was we developed a system in LabVIEW that acquires massive amounts of data and also generates algorithms on the fly. It has the ability to automate the process of tweaking parameters and testing and visualization.
So what types of commands are you referring to?
So the commands, so you saw he was able to produce speech. We can also take these speech and use those to generate commands like forward, stop, left, and right. And these can be used to operate devices like a wheelchair, for example. And I'd like to introduce Thomas Coleman, who's here now, seated in a wheelchair, and is able to use the audio to actually move without any physical movement. So normally a system like this needs to be operated by someone with a joystick, but in the case of physical disability, people don't have that dexterity, so they can't move. So using the audio, we're able to restore both communication and mobility for millions of disabled people.
Wow, is that a fantastic application or what? Yeah. Thank you, man. Great job. Great job. Thank you, Thomas.